When determining the appropriate conductor size for electrical installations, several factors must be considered. In this case, the question involves the adequacy of 4 sets of three 500 mcm conductors to supply a 1200 amps switchgear, especially concerning the 75°C temperature rating of the terminals. Firstly, let's define ampacity. Ampacity is the maximum amount of electrical current a conductor can carry continuously under specific conditions without exceeding its temperature rating. The National Electrical Code, or NEC, provides tables that specify ampacities for various conductor types and sizes at different temperature ratings. For 500 mcm conductors with a 75°C rating, the ampacity is 470 amps. Therefore, if you have 4 sets of three 500 mcm conductors, you need to calculate the total ampacity. This is done by multiplying the ampacity of a single conductor by the number of conductors in parallel. So, 4 sets of three 500 mcm conductors would have a combined ampacity of 4 times 3 times 470 amps, which equals 5,640 amps. Secondly, consider the switchgear rating. The switchgear is rated for 1200 amps. This means it can safely handle a maximum current of 1200 amps. Comparing this to the total ampacity of the conductors, 5,640 amps, it's clear that the conductors have more than enough capacity to supply the switchgear. The conductor ampacity significantly exceeds the switchgear's rating. Utility recommendations must also be considered. In this scenario, the utility inspector recommended 4 sets of three 500 mcm conductors. This recommendation aligns with the ampacity requirements, as the conductors provide a much higher ampacity than the switchgear's rating. However, it's crucial to consider the conductor temperature rating, which is 75°C, to determine the actual ampacity. Now, let's address the question of whether considering the 75°C temperature rating of the terminals is a waste of money. Based on the information, it does not appear to be a waste. The utility inspector's recommendation of 4 sets of three 500 mcm conductors is sufficient to supply the 1200 amps switchgear, and the conductors have a high enough ampacity to handle the load. However, there are additional considerations. It's essential to consult with a licensed electrician or engineer to confirm the appropriate conductor sizing and temperature ratings for the specific application. Local building codes or utility requirements may have specific guidelines that must be followed. When selecting conductors, it's important to look at NEC Table 310.15b16, which lists the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60°C through 90°C, not more than 3 current carrying conductors in raceway, cable, or earth directly buried, based on ambient temperature of 30°C. For example, a 500 mcm copper conductor with a 75°C insulation rating has an ampacity of 380 amps when installed in a raceway or cable. If the ambient temperature is higher than 30°C, a correction factor must be applied to reduce the allowable ampacity. The NEC also provides tables with adjustment factors for ambient temperatures other than 30°C. For example, if the ambient temperature is 40°C and the conductor has a 75°C insulation rating, the ampacity must be multiplied by an adjustment factor of 0.88. This means that the allowable ampacity of the 500 mcm conductor would be reduced to 334.4 amps, 380 amps times 0.88. It is also important to consider the termination temperature ratings of the equipment to which the conductors will be connected. Many circuit breakers, switches, and other electrical equipment are only rated for use with conductors that have a 75°C or 60°C insulation rating. If a conductor with a higher temperature rating is used, the allowable ampacity of the conductor must be based on the lowest temperature rating of any connected equipment. The NEC also addresses the issue of conductor dirting when multiple conductors are installed in the same raceway or cable. When more than 3 current-carrying conductors are installed in a raceway or cable, the allowable ampacity of each conductor must be reduced to account for the increased heat generated by the conductors. The amount of derriting required depends on the number of conductors in the raceway or cable. For example, if 4 to 6 current-carrying conductors are installed in a raceway or cable, the allowable ampacity of each conductor must be reduced to 80% of its value. If 7 to 9 current-carrying conductors are installed in a raceway or cable, the allowable ampacity of each conductor must be reduced to 70% of its value. Another important factor to consider is voltage drop. Voltage drop is the reduction in voltage that occurs as electrical current flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends that voltage drop should not exceed 3% for feeders and 5% for branch circuits. To calculate voltage drop, you need to know the length of the conductor, the amount of current flowing through the conductor, and the conductor's resistance. The NEC provides tables with conductor resistance values. Once you have these values, you can use Ohm's law to calculate voltage drop. In addition to the NEC requirements, local building codes and utility requirements may also have specific guidelines that must be followed. It is always a good idea to check with the local building department and the utility company to ensure that you are in compliance with all applicable regulations. Here are some additional factors that may influence the selection of conductors for a specific application. Firstly, the type of load being served. Different types of loads have different current requirements. For example, a motor load typically has a higher inrush current than a lighting load. The conductors must be sized to handle the inrush current of the motor. Secondly, the distance between the power source and the load. The longer the distance, the larger the conductor size required to minimize voltage drop. Thirdly, the environmental conditions. Conductors installed in wet or corrosive environments must be specifically rated for those conditions. Fourthly, the method of installation. Conductors installed in underground conduits typically have a lower ampacity than conductors installed in free air. Fifthly, the future load growth. It is always a good idea to oversize the conductors slightly to allow for future load growth. For example, if you anticipate that the load will increase by 20% in the future, you should increase the conductor size by one size. This will ensure that the conductors are able to handle the increased load without overheating. When selecting conductors, it is important to consider all of these factors to ensure that the conductors are properly sized for the application. Using undersized conductors can result in overheating, equipment malfunction, and even fire. Therefore, it is always best to err on the side of caution and select conductors that are slightly larger than required. Furthermore, consider the specific application. Different applications have different requirements. For example, conductors used in a hospital must be more reliable than conductors used in a residential dwelling. Hospitals require a higher level of reliability to ensure that critical medical equipment continues to operate during a power outage. The NEC has specific requirements for conductors used in hospitals and other critical facilities. In addition to the NEC requirements, there are also industry standards that provide guidance on the selection and installation of conductors. The Institute of Electrical and Electronics Engineers, or IEE, publishes a number of standards related to conductors. These standards provide detailed information on conductor ampacity, voltage drop, and other important factors. It is also important to consider the cost of the conductors. Conductors are available in a variety of materials, including copper, aluminum, and copper-clad aluminum. Copper is the most expensive material, but it also has the highest conductivity. Aluminum is less expensive than copper, but it also has a lower conductivity. Copper-clad aluminum is a hybrid material that offers a balance between cost and performance. The best material for a specific application depends on the specific requirements of the application. For example, if high conductivity is required, copper is the best choice. If cost is a major concern, aluminum may be a better choice. When selecting conductors, it is important to consider all of these factors to ensure that the conductors are properly sized for the application. Using undersized conductors can result in overheating, equipment malfunction, and even fire. Therefore, it is always best to err on the side of caution and select conductors that are slightly larger than required. Consider also the long-term implications of the conductor selection. The lifespan of conductors can vary depending on the material and the environment in which they are installed. Copper conductors typically have a longer lifespan than aluminum conductors. Conductors installed in corrosive environments may require special coatings or insulation to protect them from damage. When selecting conductors, it is important to consider the long-term costs of maintenance and replacement. If the conductors are likely to require frequent maintenance or replacement, it may be more cost-effective to select a more durable material, even if it is more expensive upfront. Also consider the availability of conductors. Conductors are available from a variety of suppliers. However, some types of conductors may be more difficult to find than others. If you need a specific type of conductor, it is important to check with several suppliers to ensure that it is available. Also, consider the lead time for delivery. Some suppliers may have long lead times for certain types of conductors. If you need the conductors quickly, it is important to choose a supplier that can deliver them on time. Furthermore, consider the reputation of the supplier. It is important to choose a supplier that has a good reputation for quality and reliability. You can check the supplier's reputation by reading online reviews or talking to other customers. When selecting conductors, it is important to consider all of these factors to ensure that you are making the best possible choice for your application. Take the time to research your options and select the conductors that are best suited for your needs. This will help to ensure that your electrical system is safe, reliable, and efficient. To summarize, ensure the conductor's ampacity meets or exceeds the load requirements, accounting for temperature ratings, dirting factors, and voltage drop. Confirm compliance with the NEC local codes and utility regulations. Consult with qualified professionals to validate conductor sizing and temperature ratings for your specific application. Considering these aspects will help optimize safety and prevent potential issues.